to calculate the area in polar, remember that we have a function whose distance depends on the angle, given like that, in polar coordinates. Graphically, let's suppose that this is the function in polar coordinates, this is the polar axis. So we are trying to calculate the area, let's say, between the first angle and the second angle. And so this will be the area that we are trying to calculate. In order to calculate this area, we are going to decompose this shape into very thin wedges here. And so we're going to integrate them. For that, let's recall how much is area of a sector of a circle. So if we have a circle like that, how much is the area of certain section here determined by an angle, say alpha. So the area of all this region, we know that the area of the whole circle is pi r squared. And so the area of just this region here will be determined by that angle. So this section here, the fraction of the whole circle, is going to be whatever this angle is divided the total thing, that is 2 pi. So the area of a section is, by cancelling here, pi is r squared over 2 times the angle, whatever angle is determine the section. So we have here very small sections here, and we're going to calculate the area of each of these sections and integrate them all. So the area of the whole region here is going to be the integral from the first angle to the second angle. And so here I should put the area of these wedges here. Following the formula of area of a section, in this case, is going to be r squared over 2 times the angle, but the angle in this case is a very tiny angle, which is just the difference, the variation of the angle theta. So this is going to be just d theta. So the area here is going to be r squared over 2 d theta. So to calculate the area in polars, we need to know from what angle to what angle, and essentially what is the function to integrate. Let's see an example. So let's calculate the area enclosed by this function in polar when the angle varies between 0 and pi. According to the formula that we just deduced, the area is going to be equal to the integral from the first angle, which is 0, and the second angle, which is pi. And so here we have to put simple r, which is 1 minus cosine squared over 2. R squared over 2 is what goes into the formula. And so once that we set up the integral, the remaining is just to integrate. We have done this integral before. In this case, we can take it out of the integral. We expand this square. We integrate each one. We have done it before. So this is going to be the integral plus the integral of cosine squared. And so evaluate between 0 and pi. We evaluate, and the result then will be 3 pi over 4. Again, I remind you to graph all the functions given in polars. So if we do our chart here, giving values to the angle and finding what is the corresponding R, we will see that this is a cardioid in this position. And the area that we are calculating is between 0 and pi. So that will be the area of this region of the heart, half of the heart. In this case, we had to calculate the area enclosed by this polar curve, but we are not set from where to where. But anyway, we have this description of one petal of the flower. So in these problems, there is no other way. Actually, in essentially all problems of area, there is no other way but graphing the curve. And so you have to graph the curve and so decide what one petal means respect to the variation of the angle. This is the drawing of the curve in Sage, though especially in these cases, drawing by hand, you really will benefit more. You can see when you plug in points that from 0 to pi half is really what determines one of the petals here. Though you could calculate also the area of any of the others, right? So since it says just one petal and all petals are the same area. So in this case, the area will be then the integral between 0 and pi half, and what you put here, as always, is r squared over 2. So in this case is sine of this angle squared over 2. Okay, do all these operations and the area of this petal should be equal to pi over 8.